Here we are in chapter 4. We're going to start talking about the applications of all these derivative things that we have used in the past. And so let's just start in with the definitions here. So we begin with extrema here. So we say that f has a relative, an absolute maximum at x equals c if f of c is greater than or equal to f of x for every x in the domain that we are working on, okay? Similarly, we can say that f has an absolute minimum at x equals c if f of c is less than or equal to f of x for every x in the domain that we are working on. All we're saying here is that this is the biggest thing all around for all the values of f, and the absolute minimum is the smallest thing around, okay? That's it. Okay. What about if it's not the biggest, but it's like the biggest kind of somewhere, right? So say you're at a peak here in the Sierras, maybe you're not at the highest place, maybe you're not at Mount Whitney, but maybe you're, at China Peak or something. So you're still sort of locally the biggest. What can we say about that? All right. So relative extrema. So we say that f of x has a relative max. Let's just abbreviate. Relative maximum at x equals c if f of c is greater than or equal to f of x for every x in some open interval around x equals c. Okay, this is going to be important in a second, and I'll come back to that. Okay. Similarly, relative min. All right. Similarly, f of c is less than or equal to f of x for every x in some open interval around x equals c. Okay, let me come back to that right now. So let's just look at a picture for all these things, okay? So I've got a bunch of points here. Starts down here, comes up, down, up, down. All right, now a few things. This point right here, see how it is the tallest one around. There is nothing that is as tall as that one. This means that the relative max occurs at D, okay? At. What is the relative max? Well, the relative max is this point, or the absolute max, right? So if you say, what is the max? This is what it is, right? This height, and this is where it is, okay? So what it is versus where it is, biggest point around, absolute max. Also a relative max, because as I'm standing right here at the top, when I look left and when I look right in the open interval around D, it is the tallest point around. Okay. So what is happening at this point here? So that is a relative maximum, right? As I stand here in the open interval around B, it is, I look left and I look right, and locally, right, inside this open interval, it is the tallest thing. It is not the tallest thing all around, okay, because something else is taller, but it is a relative max. Okay, so we've got the absolute, which is a relative, and then we've got a relative max. We can play the same game for minimums. All right, down here we've got the absolute minimum, okay, and this is the relative minimum, again, working in the open interval. As I'm standing here in this little valley, as I look right and left, I'm the lowest thing around. Okay. Now, I've got a bit of a beef here with the book. And so what about the endpoints? So you'll notice that this is an absolute max and a relative max. This is an absolute min, but it doesn't call it a relative min. This is what our book does, okay? So I'm going with what the book says here. This point, shouldn't that be a relative minimum? And the answer is, well, it kind of depends on who you ask, okay? So what I can say is that the way that our book is dealing with this is that in the open interval around E, okay? So here's the open interval, and here's the open interval. Now, can I do that? And the answer is, well, no, not like this, because this is not in the domain over here. Okay, so as we talk about looking left and right, as I'm standing right here, I have to look left and right and be the tallest thing around. But there is no looking right. There is only looking left. So what should we do with that? So our book says that this is not a relative min, and this is not a relative min either, okay? However, I have kind of a beef with that. I don't think there's anything wrong with only looking one way, and if we asked about what exactly that means, my defense would be something involving the word topology and what exactly is an open set, because is this thing an open set if sort of this is where the sidewalk ends, so to speak? And the answer is yes. Let's not worry too much about that. Just know that when you're answering things on homework, it's going to say that this is not a relative min. However, I'm good with calling that a relative min. Okay, so I'm going to let that kind of slide with what you do on a test for me, okay? But just know that when you go to do homework on the book, it is not going to call the endpoints relative mins or maxes. They can full well be absolute, but they won't be mins, okay? Again, this is where I kind of disagree with what the book says. And if you go on the internet and look up endpoints and relative max and mins, you'll see that actually a fair number of math people agree with me over what the book is, and I have some advanced math to back it up. Okay, so just throwing that out there. Let's not worry too much right now. If you want to get the right answer on your homework, that's going to be good, and we can have a discussion in our class sessions about some. It requires a bit more stuff to talk about. Okay, so we're just going to leave it there. I think they are relative mins, and our book thinks that they are not. Okay, so throw that out there. Let's keep going. So here are some more helpful pictures about extrema and when they do and do not occur. All right, so this first one here I've got, as I come down, bloop, 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 and back up, there is an absolute min, but there is no absolute max. Okay, so again, we should have put arrows on this, but okay, there's an absolute min, there is no absolute max, there's also a relative min here. Here we go. Here's one that has no absolute min and no absolute max, and also no relative extrema either. Here's one that has an absolute min, an absolute max, and an absolute min. Okay, so these two things are both relative min, but because they are the same height, we have the same absolute min. Okay, the value of the absolute min is this, right, the y value, and then it occurs at two different places. That's okay. All right, so I have both an absolute max and an absolute min. This is the absolute max, this is the absolute min. The mins occur here and here, the max occurs here. Okay, more things. Here's like a tangent kind of function, except, negative tangent. This has no absolute max and no absolute min. It's not quite as dramatic as this, or I should say it doesn't go on forever in both directions. This one is bounded on the left and the right by asymptotes here, but still has no absolute max and min. A function like this, we're going to have some theorems about. So if it is a continuous function on a closed interval, then you actually are guaranteed for it to have an absolute max and a min. So that is a good theorem there. So what I usually do at this point is have everyone say what happens at all of these points here. And so what I want you to do is I want you to pause the video and do graph 1, then I'll explain, and then we'll pause the video, you do graph 2, and then I'll explain. Okay, so pause the video here, and then come back. Good, so hopefully you didn't cheat there. What are all these points here? Well, let's just kind of go in order. Or I should say, let's work from top to bottom. S is the absolute max. And B, oh, maybe it's not B, maybe it is R. Let's see if our book, yeah, R is the absolute min. Okay. R is also a relative min. Okay, what else? I see that D, nothing happens. Right? C up here, C is going to be a relative max. B is going to be a relative min. Okay, and again, according to our book, A would be nothing, but I'm okay with calling A book nothing, me, relative max, relative max. Same thing with S, so me, relative max. Okay, I'm okay with that answer. Very good. Let's go on to graph 2 here. A little more confusing. Okay, so looks like A is the absolute min. And I can tack on me, relative min. And what else? So at B, what do we have? Okay, so B is something kind of weird. So B, here is where I am standing on the graph. As I look this way and as I look this way, it is the tallest. B is a relative max. If the point was filled in down here, it would have been a relative min, okay, because I can look left and I can look right. Okay, so B is a little bit confusing, okay, because it's a point of discontinuity. This is sort of like a half dome, right? So as you're standing, right here on the top of this thing, it's you're tallest over here, and then it just goes like that. Okay, so this is sort of the half dome point. C is like the other side of half dome, right? As you're standing, right? I'm standing right here. As I look this way, I'm not the tallest. I'm shorter. And as I look this way, I'm taller than all of those. This is neither a max or a min. So this is neither, none, whatever you want to say. D looks like a relative min. Relative min. R is going to be the absolute max and relative max. And S is going to be, again, the book would say nothing. Book, none, me, relative min. Okay. Good. Hopefully we're getting that distinction there with what I'm talking about. Okay, again, it has to do, the question revolves around what is an open set, okay? So if I say in an open set around S, this part over here is not included in the domain, and so we can't really include an open set around S, but is that really open when we're talking about a bounded finite domain there? Not finite, but bounded domain. Okay. This is a great place to pause this first video. I will pick up in the next one with more talk about relative extrema. I'll see you then.